drives a man insane. You broke my will, but what a thrill. Goodness gracious, great balls of fire.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever with the great Jerry Lee Lewis and the classic song Great Balls of Fire, which could not be more appropriate when studying the trigonometry. I know you love the trigonometry, and we are going to continue our study by exploring the sine rule. 'Tis an awesome rule, so let's get to it, shall we? All right, so here it is. In any triangle ABC with sides little a, little b, little c, and units, and opposite angles, cap A, cap B, and cap C, respectively, you know the relationship. We have this relationship, sine of the angle A over the length of side A equals sine of the angle B over the length of side little b, and they're all equal to one another. Sine of angle C over the length of side little c. Those are all equivalent. So we can use proportions to solve for things we don't know. And we can also write it like this, where we invert the fractions as long as we are consistent. There is a nice little proof of this right here. You can pause and take a look. Here it is. We already know the formulas used to find the area of any triangle using the sine rule. And if we set them all equal to one another, which they are for any triangle, and divide all of them by 1/2 ABC, it results in the sine rule. So if you'd like to take a closer look at that, just pause and you can do so. We are going to move on to our first example. So here we go. We are being asked to find the length of side BC, which is opposite angle A. So I'm going to go ahead and label it little a, okay? And so we have to ask ourselves, let's start with little a. A is opposite the angle 113 degrees. So I know that little a over the sine of 113 degrees is going to be equal to some other relationship like this, some other side length divided by the sine of the angle opposite. And I have the length, it's already given to me here, 18 meters, and it is opposite the angle 41 degrees. So this is equal to 18 over the sine of 41 degrees. Okay, now don't get freaked out by the sign of an angle. You already know it's just a number. It's just a way to represent, in this case, decimal numbers. So I'm going to cross multiply here, and I'm going to say that A sine 41, or A times the sine of 41 degrees, is equal to 18 times the sine of 113 degrees. Okay, and then we divide both sides by the sine of 41 degrees because it's just a number. And don't find the sine of 41 and put in the decimal and then divide. Leave it as the sine of 41 until you're ready to use your calculator. So I'm going to divide this side also by the sine of 41. These cancel because the same thing over the same thing is equal to 1. And so then we get A is equal to 18 times the sine of 113 degrees divided by the sine of 41 degrees. Okay, and then that is equal to, well, let's wait and see here. Go to our calculator. So we're going to do, since we want it all on top and we have a fraction, I'm going to use parentheses. 18 functions sine, and oops, I forgot, I didn't get the 1, did I? 18 sine, go back here, and it's 113 over sine 41. Hopefully I can remember that. Sine of 113, and all of that is divided by, I believe, the sine of 41. I believe that's right. I'm not going to check. I'm going to roll the dice and gamble. 41 And don't forget to check if you're in degrees or radians. The default is radians, so I'm going to go to degrees, hit enter, and we're done. And so I believe it said round to 2 decimal places, so that would be 25.26. So A is equal to 25.26, and it was a sine of 41. And this is meters, okay? So not a big deal, I hope, not a big stretch there. So let's go on to the next one where we're asked to find an angle. And they're not always going to give you the triangle, so you might have to draw your own triangle. So, like in this example, find correct to 1 decimal place the measure of angle C in triangle ABC if AC equals 8, AB equals 12, and angle B measures 28 degrees. Okay, so let's see. You can sketch any old triangle, but I'm going to try and do it somewhat to scale. Let's see. A, B, so that's 12. And then, let's see. Angle B measures 28 degrees, so I don't know. That's something like, maybe something like this. And that's 8. Do they tell me that? Oh no, AC equals 8. So that seems about reasonable. So this is 8. And what do I know? Angle B measures 28 degrees. Okay, and so I'm looking for angle C. Okay, so I always start with what I'm looking for. I'm looking for angle C. Okay, and the only way to look for capital C is to look for using the sine of capital C. Well, the sine of capital C over the length of the side opposite it, which is going to be 12, okay, over 12, is equal to, and the only other angle I know is 28 degrees, yes, and opposite it is a length of 8. So that's going to be equal to the sine of 28 degrees divided by a length of 8. So again, I'm going to cross multiply here, and I am going to say that 8 times the sine of C is equal to 12 times the sine of 28. And I'm solving for C, so I'm going to divide both sides by 8. Okay. And so then I get the sine of C is equal to 12 multiplied by the sine of 28 degrees divided by 8. Okay. Because 8 over 8 cancels, because 8 over 8 is equal to 1. And I'm going to move my calculation up here. And I have to solve for the angle C. So I'm going to say that C is equal to the arc sine. Remember, to find an angle, we use arc sine of all of this. So that's going to be the arc sine of 12 sine 28 degrees, all divided by 8. Okay? And remember, this is the same thing as sine negative 1. Okay, but I just use this because the calculator Desmos has it. So C equals, and now I got to go to the calculator, 12 sine 28 divided by 8. 12 sine 28 divided by 8. So now I'm going to go, I got to do arc sine functions, arc sine, and I'm going to do the parentheses to keep all this on one side. So that's 12 sine 28, and that is divided by 8, I believe. And, oops, I have to put divided by. Oops, nope, I didn't do it, did I? I put it in there wrong. So this is divided by 8, and I got to get rid of that 8, sorry. So that's what it should look like. And I get, I'm already in degrees because I already changed it, and I get 44.8 degrees. Okay, 44.8 degrees. So C is equal to 44. Oops. 44.8 degrees. And for my drawing, I guess that seems reasonable. But let's see. The other possibility is that if you can imagine, if this is 44.8 degrees, can you imagine if I drew triangle ABC maybe like this? Is it possible? If I drew it, all I know is that this is 12. This is 8 right here. Again, A, B, C, right? I could draw it real skinny, yes. And this length is 12, this length is 8, and B still looks to be about 28 degrees. I just kind of swung this leg over here maybe a little bit. If you can think of it as an arc, if I just swung that leg and then I could have this triangle here, that's possible. So that means angle C could be a different measure. In fact, instead of being acute, it could be obtuse. So the way I find that is anytime I solve for an angle, I say, or it's equal to 180 degrees minus 44.8. Okay, which is equal to, I'm going to repeat the 44.8 degrees, or, and 180 minus 44.8 is equal to 135.2 degrees. So there are two possible solutions, okay? And then you also have to make sure that if it is the obtuse angle, okay, you have to do a check here because it is possible. Oh, I'm so popular. There goes my phone. Okay. You have to do a check here that the obtuse angle, obtuse is greater than 90, plus the given angle is 135.2 plus 28. Is it less than 180 degrees? And the answer in this, the answer is yes. 135 plus about 30 is 165. Is yes. So then that means that is a good answer. If it was greater than 180, no two angles in a triangle can be greater than 180 because the sum of the three angles has to be 180. So you always have to check that. All right, that is all that I have. We will sign out and see how the great Jerry Lee Lewis is doing. Oh, yeah. And B-Dog is out.